third case study of how we understand the world, how we make an inference about a three-dimensional world from a two-dimensional array, is the case of depth. So you don't see all of these figures as lying along the same plane. You see, for instance, the man in front of the house. And it's an interesting question how you do this, what cues your mind uses to figure out the relative locations of things in space. For a more dramatic illustration, you could look at this, and it's a two-dimensional figure, just on a two-dimensional array, but it doesn't look two-dimensional. Things are happening to it that give you the illusion of a three-dimensional thing. So what's going on? Well, there are different answers. One answer is the size of things. So this cartoon illustrates that if you see something that's really takes the size of your thumb, and it's a person, most likely it's not a tiny person floating in the air in front of you, rather it's a person at a distance. And so knowing the size of things, the rough size of things, can help you infer how far away they are. Then there's interposition. So go back to this picture. The man is in front of the house because the man interrupts the house itself. In other words, you could fully see the man, but the house is blocked by the man, and so, the man is in front of the house. And as I walk along the stage and walk back and forth, I change in size, but you know I'm not actually changing size, so you infer that I'm moving away from you or close to you. And as I walk in front of something, you don't assume that my body adopts some weird shape where I'm half object, half person, but rather you assume that I am moving behind that object. Then there's other, more subtle cues that psychologists have studied. So consider these two illusions. This is the Mueller-Lawyer illusion. And what's cool is, if you're like most people, you will see the line on top as longer than the line on the bottom, even though they aren't. It's an illusion created by the context in which the lines are shown. And so what can we say about this? Well, the standard explanation here is that the top horizontal line for the Mueller-Lawyer illusion looks longer because we infer that it's further away. The things on the side lead us to infer that it's from a distance because it seems to be pushed away from us. And so because it's a distance, it occupies X space on our retina, but we assume since it's further away, it must really be bigger than X. And so in our minds, just as we adjusted the colors of objects in shadow, we adjust our perception of the size of objects due to distance cues. Similarly, the inward pointing line looks closer, and if something seems to be closer, we think it's smaller relative to the same amount of retinal coverage for something that we think is bigger. Or as another case, the Ponzo illusion is the same thing. Because of the converging lines, you get the impression that the line on top is further away. And since it actually takes the same amount of space on your eye as the line on the bottom, you then infer that it must be bigger. And none of this is conscious. This goes back to the rules of language. We're talking about all these subtle rules of language where you understand the pig is eager to eat is different from the pig is easy to eat. And you understand it immediately, but you can't articulate why. And the same with the cues. You immediately, parts of your understanding of scenes guide you to think that the top line is longer than the bottom line, but you can't say why. And this is why psychology is often so interesting. And it's why the study of vision is in some regards similar to the study of language, in that they both explore mental mechanisms that work with extraordinary speed, unconsciously, to yield some understanding of the world. And I will end with another example on depth, one of my favorite examples. These are the Shepard tables, developed by Roger Shepard. These look like different tables. And if you just show these to people and you ask them something like, which would be easier to get through a door if you have a thin door, people say the one on the left. They look at very different tables. But this is an illusion set up by cues of depth perception. And I'm going to show you this as an illusion in this way. If you think I'm doing some sort of trickery, a rectangle here covering the table on the left. And now let's just move it. And as you could see, they match. And based on what you know about depth perception, thinking about the Mueller-Lawyer illusions and the Ponzo illusions, thinking about the cues to depth, I'll leave it as a take-home exercise to explain why the Shepherd tables work so well. And that's where I'm going to end my discussion of perception, through examples of these unconscious and lightning-fast cues, beliefs about how the world works that can create illusions in the context of a psychology experiment, but in real life allow us to understand the physical world so well.